Hello, welcome to MatheMARK Tutorials Episode 1. Have you ever thought of having difficult time in math, such as, oh no, stressful, and that again lines? Don't worry, because for this episode, we're gonna talk about graphing exponential functions in this form, where the exponent x is the input. We will focus on the restrictions, graph types, graphing checklist, and the graph. So first, the base should be greater than 0 always, but not equal to 1. It's because 1 raised to any number, large or small, is simply 1, and it's constant, which doesn't match to the definition of an exponential function. Exponential functions do not give a constant change. When b is less than 0, there are inconsistencies, such as these examples. As we can see, there is a shift from negative and then to positive and then to negative and so on and so forth. The exponent can be any real number because there are no restrictions for the exponent. Recall the two exponential properties, the negative law of negative indices and the rational indices. They still both give positive results, greater than 0. Given this, n is always greater than 0. Imagine y equals f of x equals n. This explains why there is a horizontal asymptote in exponential functions. Let's talk about the graph types. This increasing at different rates. Let's focus on the first one. As you can see, the slope of the graph increases. That is why the graph is increasing at an increasing rate. For the decreasing rate, it started with a steep slope and the slope became less. And these are the following cases for each. And there are two cases is because of the law of negative exponents, where the base and exponents are coexisting. Same as for decreasing one. This time, however, the slope is going down. But as we can see at an increasing rate, the slope absolute value increased. That's why it is an increasing rate. This one is started almost perpendicular and it's starting to get flatter. And these are the two conditions for each, and again same with increasing functions. It's because of the law of negative indices. Now, let's talk about the checklist that you will need. First, the values of a, b, and m. The domain, which is always real numbers for all exponential functions. For the range, it's greater than h, y is greater than h if a is greater than 0. Otherwise, it's less than y is less than h. The horizontal asymptote is based on the value of h, which is simply y equals h. These are lines that the graph approaches but not touches, and usually they are just dotted lines. The y-intercept is simply when x is equals to 0. The x-intercept is the other way around, y equals 0. But not always that there is an x-intercept, because it only occurs only if a and h have opposite signs. And table of values that requires at least 3 other x values to substitute. Now let's focus on the example I showed earlier. From the given form, the values of a, b, m, and h respectively are 1/4, 1/6, 1, and -4. From these first three, the graph is decreasing at a decreasing rate. The domain is always all real numbers. This is because there are no restrictions for x. For the range, since it's greater than a is greater than 0 and h is equal to -4, then the range must be greater than -4. It's because the graph lies above the horizontal asymptote, which is equal to y equals -4. Let's go to the y-intercept. It's simply when x is equals to 0. By substituting it in the equation, we replace x with 0, we simplify, and according to the law of negative exponents, we can reciprocate the base and make the sign of the exponent the opposite, which gives us this one. 1/4 times 6 squared minus 4, which gives us 1/4 times 36 minus 4. By using the GEMDAS or PEMDAS rule, it becomes 9 minus 4 equals 5. Writing it in the point form, it's 0, 5. And this is our y-intercept. For the x-intercept, it's a bit of a long process. And since a is greater than 0 and h is less than 0, they are opposite signs, therefore they have an x-intercept. It's simply substituting y equals 0, therefore 0 is f of x becomes 0. We multiply both sides by 4 according to the multiplication law of equality. Imagine there's a weighing scale, and in order to make that balance, you must place the equal amount on both sides. Same applies here in the equation, which gives us this one. After that, you distribute 4 to each term, which gives us 1/6 raised to x minus 2 minus 16. And then same thing, we add 16 on both sides. And according to the law again of negative exponents, we make the base whole numbers. We change it from fraction to whole numbers, and we make the sign of the exponent the opposite. So that, and then we distribute the negative sign to each term here. That's why the resulting term is 16 equals 6 raised to negative x plus 2. Since we cannot express both sides in terms of the same base, we will have to use the concept of logarithms. We will get the log on both sides, log of base 10. And then based from the power law, the index here will become the coefficient, which gives us this one. And then we distribute log 6 to each term here, which is negative x log 6 plus 2 log 6 equals log 16. And then we subtract 2 log 6 on both sides to maintain the balance of the equation. And then again, we do the power law, but this time it's the other way around. The coefficient becomes the index here. That's why 2 log 6 becomes log 6 squared, which is became log 36. And then based on combining the differences in single log, we will divide m and n together. That is why log 16 minus log 36 became log quantity 16/36, which can be further simplified into 4/9. And we divide both sides by negative log 6 to isolate x, which gives us an approximate value of 0.45. Writing it in point form, it's 0.450, and that is our x-intercept. For the table of values, we can assign any value for x. Suitable value, I would recommend that the values you will use for x will not give very large amount value for y. We use only small numbers to make our lives easier. We can do it manually or by a use of calculator. That is why the values of y when the values of x are substituted are the following. And hence we are complete with our checklist. For graphing, we plot the x-intercept, the y-intercept, and the horizontal asymptote. And we must label the horizontal asymptote y equals -4. And then we plot the other 3 points, that is based from the table of values. And after that, we simply connect all these points. There. This is our final product. I would like to thank the following teachers, Ms. Horado and Mr. Villares, for teaching us the concept of logarithms. Thank you to Mr. Villares because he introduced us about the concept of logarithms and exponential functions when we were in grade 10, and for Ms. Horado for further deepening our knowledge and for giving us some tips about screen recording and other types of technology. I hope you enjoyed this first episode of MatheMark tutorials.